Okay, so this is how you do problem number 5 on the chapter 15 homework. So this problem asks us to, part A of this problem asks us to show that the position of the particle is given by this equation. And a lot of the parts of this problem basically come from recognizing the variables and what each of them represents. So from the problem itself, I have concluded that the amplitude is like 0.02 meters, and which is equivalent to 2 centimeters, and the frequency is 1.5 hertz. And also given in the problem is the phase shift is 0 because it starts at the origin at t equals 0. So therefore the phase shift must be equal to 0. Okay. So once you recognize these variables, you can start plugging them into the equation. So x equals x max, or amplitude, we know that. Cosine, then omega t plus this angle. However, we do not know omega. This can be solved by recognizing that time is the reciprocal of frequency and is also equal to 2 pi over omega. And if we use these two equations, 1 over f equals 2 pi over omega, we can isolate omega and solve for that in terms of the frequency. And for this example, I got 3 pi radians per second. And then we're going to skip over to my notebook for parts B, C, and D. So parts B asks us for the maximum speed and the earliest time that the particle has a speed. So you have to keep in mind that the maxes and mins of basically the extreme values of a function occur at the zeros of their derivatives. So in order to get the maximum value for speed, I had to take the derivative of it to get acceleration, and then I set that equal to 0 given our angular velocity, amplitude, and phase shift. So I did this. This arrow points to me solving for it, and go all the way down, and I got t equals 1.6 seconds. So we know that it's the earliest time that it reaches its maximum speed is 1.6 seconds, but we're not done yet. We have to solve for this speed. So all we need to do is plug in, not 1.6, I'm sorry, 1 over 6 into our velocity equation. So instead of t in this velocity equation, we are just substituting it for 1 over 6. And for that, I got negative 0.19 radians per second, or if you're talking about it in terms of speed, that's just 0.19 radians per second. The same thing goes with acceleration. So in order to find the maximum acceleration, you have to find the maximum jounds, the zeros of jounds, which is the derivative. I think it's called jounds, I'm not sure, but you just get the derivative of the acceleration or the fourth derivative of position, and then you repeat the same procedure. Find the zeros and then plug them into acceleration to get that value. And finally, for displacement, displacement is just the integral of velocity from a certain limits of integration, and they were given in the problem, which is 1 to 0, and I simply just integrated them, and I got 0.04 meters. So yeah, that's how I did problem number 5 on the chapter 15 homework.